Hello, in this episode, we'll go over an example with Lime doing Boston housing price prediction. Okay? So this is unlike Shapley value method. This is a localized method, so it can explain only one observation at a time. But the merit is that it is a relatively faster method when the data is very large than Shapley value method, computing all combinations of subgroup and the marginal influence can be very time consuming. In those cases, Lime can be a quick way to check how each factor's influences by checking a number of sample points. So again, this is a method that's a very localized method. So you target just one local point here and then see and change, slightly perturb each features and see how it influences the prediction here, right? Okay, so let's go and see a code. Okay, so this is the same Boston housing price data. And this time we need to install the Lime package instead of Shapley value package. I think it's almost done. Okay. All right. So let's import the libraries. This time we do need, well, we did import it. We need to import the libraries. Okay. We'll do it later. So let's first upload the data. It's not done. Oh, we shouldn't import Shapley value. And let's import the Boston housing price data, put it in a data frame, and then, well, we split the test and train data. And again, what we have done several times before, we standardize and convert to NumPy. After that, we do define a model, again, simple neural network with 10 hidden nodes and a linear at the output to predict the price. So let's build a model and quickly train it. So it does give this prediction, so we can make it. And again, the predictions are sort of lining up. Now comes the Lime part. So we'll have to import the Lime library. And here, how you call it is that the explainer, what we call explainer here, is from the Lime package. It's a Lime tabular explainer. So you put the xtrain variable and the feature names. I actually predefined the features here. The column names I'm defining as. So when we plot it, we know which one is what. Okay. And the class name is median value here, and it's a regression mode. Okay, so that was quick, isn't it? So let's have the test. So we have a white test of two samples here, two data points, 10.9 and 33.8. That's the price. The model predictions are here 8.93 and 34.48, not too bad. For this, it's here. For this, it's here. Okay. So the explainer, so we created a model explainer. So with this explainer, put the X test data, the first test data, and prediction model, and then show here. So show in notebook, that's the command. And it does show here the influence. Something to notice that the intercept here is 21, right? But from that intercept, the prediction local becomes minus 1.1, and here are some of these variables influences. Okay, so negative forces and positive forces, and all into this. Or you can have it here in a red and green plot, which basically does the same thing. But anyway, so where do we get the estimate, the Lime estimate? So the prediction is minus 1.15 here. So we can compute here each influences the Shapley value as a list. If you sum them up, that's minus 22. okay? So the Lime intercept in our case is 21.079, so it's slightly changed, okay? 21.079. And this influence here, minus 22, well, now we actually have to change it, isn't it? The intercept, 21.079. Okay, 21.079 plus what we got here above, the 23. Will get us minus 1.15. So that was kind of the prediction for the local. Okay, we can do it for the second data point as well. So let's do the second X test 1, isn't it? So here we have an intercept of 12 and the prediction local 26. The original price was 33 or something like that, isn't it? The second observation price was 33. So how does that come out to be? So 26, it's a little bit off, but that's okay. Right? So we have a plot here. So what do we get is that if you have all this Lime predictive variable and sum them up, it's 13, okay? So from the intercept, which is the base value, 12.574, right? Add all the influence of the Lime contribution, we'll get you 26, which is the prediction here for the local price. Okay. So this is sort of how to use the Lime method to explain which variables are very important, like Charles River location and all these kind of things, and check for each data point. The merit of it is although it's local, the merit is it's very quick. Okay. Thank you for watching this app.